Everyone thinks they know why China went to the moon. National pride. A space race reboot, showing the world they could do what America did 50 years ago. And sure, there's truth in that. But if you actually look at what China's doing up there, something doesn't add up. Because proud nations plant flags and go home. They don't keep returning. They don't land on the moon's hidden hemisphere. They don't bring back rocks from craters older than continents. And they definitely don't start building things. So here's the question nobody's asking. What if China's lunar program was never about exploration at all? When Neil Armstrong stepped onto the moon in 1969, humanity declared victory. 6 Apollo missions, 12 astronauts. Case closed. We knew the moon. Except we didn't. Because every single Apollo landing happened on the near side, in the safest, flattest spots engineers could find. The Lunar Maria, those dark volcanic plains. That's it. A geographic area smaller than Texas. And for 50 years, we extrapolated everything we believed about the moon from that tiny window. It would be like studying Earth by only visiting Kansas. The Himalayas? Never seen them. Antarctica? Doesn't exist in your dataset. Massive regions went completely unexplored. The far side remained a mystery. The poles were ignored. The deepest impact basins were considered too risky. So when China's space program emerged, people framed it as playing catch-up. But that misses the point. Apollo was designed to win a moment. Plant the flag, collect rocks, come home alive. It was never built for permanence. Each mission lasted days. Astronauts couldn't stray far from the lander. Everything came from Earth. There was no plan for what happened after. China took a different path. They moved in phases. Orbiters first, mapping everything. Then landers to prove precision descent. Then rovers to survive lunar nights and test mobility. Then sample return. And only after all that, infrastructure testing. No crew pressure. No televised countdowns. Every mission fed into the next. By the time China started planning human missions, they understood what Apollo never learned. What actually limits staying on the moon? Starting with, what's on the other side? January 2019. Chang'e 4 descends toward the far side of the moon. No direct communication with Earth. No real-time control. This is why no one had tried it before. China solved it by launching Kuekiao, a relay satellite positioned beyond the moon that could see both Earth and the far side simultaneously. An engineering solution to a problem most agencies decided wasn't worth solving. Chang'e 4 touched down inside the South Pole Aitken Basin, a colossal scar 2,500 kilometers across and 13 kilometers deep, the oldest, largest crater in the solar system. When it formed over 4 billion years ago, the impact punched through the lunar crust, exposing mantle material that had been buried since the moon's formation. The far side isn't just geographically different, it's geologically different. The near side has smooth volcanic seas. The far side is rugged, ancient, thick with highland crust. Scientists had theories, but theories aren't data. So China went, and what they found started rewriting everything. The rocks weren't what models predicted. The mineral compositions didn't match, and the ages told a story nobody expected. Then, Chang'e 6 in 2024 brought back nearly 2 kilograms of far-side material. First samples ever returned from that hemisphere. And when scientists analyzed them, the moon stopped making sense. Volcanic activity that should have ended billions of years ago apparently continued far longer. The moon stayed geologically active much deeper into its history than anyone thought. Why does that matter? A moon that cooled slowly might still be thermally active in certain regions. It could harbor volatiles, water ice, chemical deposits in places we haven't looked. It's more complex, more dynamic, and far more useful than the dead rock we assumed. But buried in those samples was something else that changes everything. Water, not lakes. Molecular water chemically locked inside lunar minerals, sitting there for billions of years. And alongside it, helium-3, a rare isotope that barely exists on Earth. The entire planet contains maybe 15 kilograms, but the moon has over 1 million tons in its regolith. If fusion becomes viable, helium-3 is the cleanest fuel imaginable. No radioactive waste. Theoretically, 40 tons could power the United States for a year. But China isn't mining helium-3. The technology doesn't exist yet. What they're doing is more strategic. They're creating the definitive map. Where do resources exist? How much? How deep? How hard to extract? What equipment is needed? You don't build bases on hope. You build on data. China is converting possibilities into certainties. Geography stopped being abstract. Location matters. And one place stands out: the lunar South Pole. The sun rises and sets every 14 days. 2 weeks of scorching heat. 2 weeks of freezing darkness. Temperatures swing from 127 Celsius to negative 173. Solar power only works half the time. But at the poles, the sun hovers near the horizon, grazing mountain peaks and crater rims. Some elevated ridges receive sunlight 90% of the year. Reliable, uninterrupted solar power. And just meters away, lie craters so deep, sunlight hasn't touched their floors in 2 billion years. Permanent shadow. Temperatures below negative 200 Celsius. Colder than Pluto. At those temperatures, water stays frozen indefinitely. Power and water, side by side. Physics created this convergence, and every space agency eventually arrives at the same conclusion. There's really only one place to stay. China's missions are heading there. So is NASA's Artemis. So are missions from India, Japan, and private companies. This isn't copying, it's convergent engineering. Physics forces everyone to the same answer. The moon has only a few locations where conditions for long-term presence align: ridges with perpetual sun, craters with frozen volatiles. These aren't destinations. They're bottlenecks. And they're extremely limited in area. What happens when multiple nations want the same square kilometer? The Outer Space Treaty says no nation can claim sovereignty, but it never anticipated the most valuable lunar real estate fitting inside a few football fields. Whoever maps these locations first, whoever builds there first, doesn't just visit. They define how everyone else operates. The next missions represent a fundamental shift. Everything before was exploration. What comes next is about using the moon. Chang'e 7, mid-2000s and 20s, is prospecting. Ground-penetrating radar, drills, spectrometers. The goal is determining what resources can actually be extracted and how. Where is ice distributed? How deep does it extend? How pure is it? These aren't academic questions. They're engineering. Requirements. The difference between knowing water exists and knowing you can access it with real equipment. Then, Chang'e 8. This is where language changes entirely. It's designed to test in situ resource utilization, making things from moon dirt. The mission will test 3D printing with lunar regolith, melting it, shaping it into structural components, testing if they survive the lunar environment. If it works, you're manufacturing on-site, not hauling everything from Earth. Chang'e 8 will also deploy construction robotics. Machines that dig, move material, assemble structures, that interact with the surface in deliberate, repeatable, scalable ways. This is where exploration ends and settlement begins. This is the line. Exploration on one side, infrastructure on the other. Chang'e 8 crosses it. Once you cross, you're not visiting. You're occupying. Let's be clear. China didn't go for prestige. They went to establish conditions for permanent human presence. they're not claiming. Territory. No borders in space. No legal framework for ownership. What they're claiming is operational control. The ability to generate power where it's reliable. Knowledge of where resources exist and how to extract them. Technology to build without Earth-based supply chains. And relationships to involve other nations in a framework China defines. This feeds into the International Lunar Research Station. Modular, multinational, planned for the 2030s. Open to countries lacking resources for their own programs, offering access, collaboration, participation, but on terms set by those who arrived first and built the foundation. In space, control doesn't come from flags. It comes from being the infrastructure others need. The race was never about landing first. Apollo answered that in 1969. The race now is about who stays, who builds systems that last, who defines how the moon gets used. And while the world watched SpaceX and NASA, China quietly spent 20 years answering a different question. Not can we go, but can we live there? Mission by mission, they're proving yes. So when you see headlines about China landing on the moon, don't think symbolism. Think infrastructure. Think South Pole. Think water, power, bottlenecks of survival. The moon isn't an empty frontier. It's a contested resource. And the nation that masters it first won't just visit the stars. They'll control the gateway to everything beyond.